This problem asks for the arc length of a polar curve given by r equals 1 plus sine theta from 0 to 2 pi. So before we can use the formula, we need to find the limits of the integration. So let's graph 1 plus sine theta. Because this is a curve involving sine, then it must be symmetric with respect to the line pi over 2 equals theta. So if this is my pole and this is my polar axis, it is symmetric with respect to the line 0 is equal to, theta is equal to pi over 2. So to graph this, I'm going to use angles from the fourth quadrant to the first quadrant. And so I'm going to use the following values of theta. Negative pi over 2. Because this is sine, then I'm gonna use negative pi over 6, 0, pi over 6, and pi over 2. After graphing that in the fourth and first quadrant, I will simply copy it into the second and third quadrant because, like I said, this is a sine curve, and so it is symmetric with respect to the line theta equals pi over 2. So here we go. At negative pi over 2, sine negative pi over 2 is negative 1. So 1 minus 1 is 0. So our point is at 0 at negative pi over 2. At negative pi over 6, sine of negative pi over 6 is negative 1/2. Negative 1/2 plus 1 is 1/2. So at negative pi over 6, somewhere here, the value of r is 1/2. So if this is 1, this is 2, this must be 1/2 right there. And I'm going to copy that onto the third quadrant. So right here. If theta is 0, sine 0 is 0, 0 plus 1 is 1, so the point will be here. And I'm going to copy that as well onto the theta, when theta is equal to pi. Okay, when theta is pi over 6, sine pi over 6 is 1/2, 1/2 plus 1 is 3/2. So it's gonna be 3/2, so that's 1, 2, so somewhere here. I'm going to copy that onto the other side as well. And then finally at pi over 2, sine pi over 2 is 1, 1 plus 1 is 2, so there is our graph. It is a cardioid, okay? Okay, so now I know my limits of integration. It's going to be from negative pi over 2 to pi over 2. And I'm just doing half of the cardioid, so I will multiply the whole thing by 2. So here we go. So S is equal to 2 times the integral from negative pi over 2 to pi over 2 of the square root of our r is 1 plus sine theta, and that must be squared. And then our formula requires that we need to get the derivative of r with respect to theta. So r prime is cosine theta. So plus cosine theta squared d theta. Simplifying this, we get 2 times the integral of negative pi over 2 to pi over 2 of 1 plus 2 sine theta plus sine squared theta plus cosine squared theta d theta. We notice that we can simplify this. This is equal to 1. So our integral becomes 1 plus 1 is 2 plus 2 sine theta. we can factor out the square root of 2. And get 1 plus sine theta. So we can write this as 2 square root of 2 from negative pi over 2 to pi over 2 of the square root of 1 plus sine theta. From techniques of integration, we can multiply this by 1 in the form of 1 minus sine theta over 1 minus sine theta. This is understood to be over 1. My goal is this. When I multiply 1 plus sine theta by 1 minus sine theta, I'll get 1 minus sine squared theta, which is cosine squared theta. The square root of cosine squared theta is simply cosine theta. While the denominator is the same, 1 minus sine theta d theta. So now I can use u substitution. If u is equal to 1 minus sine theta, then the derivative of u with respect to theta is negative cosine theta d theta. So solving for du, we get du, negative du is equal to negative cosine theta. Cosine theta d theta. So now because I changed my limits to my variable to u, I will have to change my limits here. So let's do that here. If theta is equal to negative pi over 2, so if theta is negative pi over 2, then u is equal to 1 minus sine of negative pi over 2. Sine of negative pi over 2 is negative 1 minus 1, that will give me positive 2. And if theta is pi over 2, then u becomes 1 minus sine pi over 2. Sine pi over 2 is 1, 1 minus 1 is 0. So our problem now becomes, here we go, 2 square root of 2. At negative pi over 2, our value of u is 2. And at pi over 2, our value of u is 0. Now this becomes negative du over the square root of u. So using power rule, we can write this as, let's pull out that negative sign. So this becomes 2 to 0. And we can write this as u to the negative 1/2 du. Now, there is a property of definite integrals where you can interchange the limits and make this positive. So our integral now becomes 0 to 2, but this time it's going to be positive, of the integral of u to the negative 1. Let's copy that down because I have my integral sign here. So using power rule, the integral of u to the negative 1/2, if we add 1, we'll get 2 over 2 times square root of u, right? Because it's going to be square root of u over 1/2, and so that's going to be 2 square root of u. So 2 square root of 2, the integral is 2 times square root of u, evaluated from 0 to 2. So this will give me 4 square root of 2. If u is 2, then I get square root of 2 minus square root of 0 is 0. Well, square root of 2 times square root of 2 is 2. 2 times 4 is 8. So the length of the curve is 8.